Yo, how's it going, guys? This is Ali from the AI Enthusiast, and today we'll be talking about lecture 4 of the Artificial Intelligence Explained series. So, in this lecture, I'm going to be talking about the different types of AIML tasks. Let's jump right into it. So, as you can see here, there's 5 tasks, and AIML, Artificial Intelligence Machine Learning, is all about making decisions. So, the first one is classification. So given some data, we want to determine what class or category it belongs to. So by the way, I'm going to be showing examples of these in the future slides. So I'll just keep it high level for now. But, for classification, think of like given an image, determine if there's a cat in the image versus a dog. So there are 2 categories there. The second one there is regression. So given some data, predict or estimate some value. So estimate some value. So basically, it's the same, very similar to classification, but instead of us choosing a category, we're choosing like a decimal value. So imagine if you have a bunch of input data like number of rooms, square footage, and then given this input data, you want to predict the price of a house. So now the thing that you're predicting, like it can take on the value from 0 to like some large value like 10 million. So house prediction is a regression task. You can see how there's not really a category we're predicting. So let's go to the clustering. So clustering is grouping a data set into chunks or blobs. So then if you have your data, lots of times we have complex data and we want to group it together. So we want to say, okay, this data point belongs to a cluster and it doesn't belong to these other clusters. It actually gives us a lot of insights, and also there's a lot of cool work being done in that domain. But yeah, so clustering is like grouping together your data. Reinforcement learning is just the way it sounds, the way we teach pets or animals. So you have the computer is going to make a decision, and then there's going to be a reward for that or some sort of penalty. And based off of that, the computer is going to learn over time what to do in a particular situation. Then you finally have dimensionality reduction. This one's kind of a little hard to tell, but it's kind of like clustering where we're trying to make sense of our data. So a lot of the times we have a lot of data. A lot of the times we have a lot of data in the machine learning and AI space. So how do we reduce or make that data simpler for us humans to understand? And so that's what dimensionality reduction is talking about. Yeah, so let's just jump right into the next, some of the details. So the first thing is classification. As mentioned, we are going to be predicting some category or class given the data. So we have 3 examples here. So given an image of a car, determine what kind of car it is, whether it's a van, truck, sedan. The second is where we have an audio file or recording, and we want to determine which person it is. So think of like Siri. Siri needs to determine whether or not to respond if it's the right human being, like the owner of the cell phone or not, speaking into the phone. Then the third is given the snippet of text, determine if it has positive sentiment or negative sentiment. So Amazon really cares about that so that they can recommend good products to their customers. Let's move on to then regression. So regression is given some data, instead of predicting like a class or a category, we want to predict some sort of decimal value. So as mentioned, like house price prediction. So given like these inputs like square footage, pin code, number of bathrooms, historical market activity, we want to predict the price of a house. And then likewise, like for stock prediction, you can look at historical performance, you can look at related stocks, and then accounting statements that are publicly available. And then you can make a prediction on a stock. And you can see how this is not choosing from a category or class, rather we are basically determining some sort of decimal value. So that's regression. And then as mentioned, clustering is where we're grouping our data. So like the image on the bottom right, if you take a look there, K-means clustering is a common clustering algorithm. So imagine we had some data, we had 2 columns in a table, and so I can plot column X and then column Y. And we have 3 clusters here. It looks like we have 3 blobs. So k-means clustering would allow us to determine those 3 blobs. So essentially we can say, okay, there seems to be like 3 groups in the data. So that's clustering. And then finally, we have reinforcement learning and dimensionality reduction. So as mentioned, reinforcement learning is where the computer is going to learn over time from its mistakes. And so like playing a game is a really good example where the computer will play it several times. It'll come across different scenarios. And for each scenario, it's going to try different things. And over time, it's going to learn what the optimal thing is for a particular scenario. So those 3 examples, Atari, AlphaGo, chess. Those are some well-known examples. Then let's go to dimensionality reduction. So this is where we are taking our data. So our data can be very complex and we want to simplify it. So a good example of that is on the bottom right. So human beings, we live in 3 dimensions. So let's if we take our hand and we cast a shadow on the wall, we can see how the shadow is 2 dimensions, obviously, and then our hand is 3 dimensions. But in A, we can actually see that the shadow, it looks like a hand. So we can draw some conclusions about the actual 3D object. But if we took a projection, if we simplified our data and we reduced the dimensionality, we went from 3 dimensions to 2 dimensions, and on the right, we saw that kind of shadow. If it was like a very straight line, it would be very hard to tell that the shadow was of a hand. And that's what we mean by dimensionality reduction. In this example, we're going from 3 to 2 dimensions, and you can see how there's an optimal way of doing that such that you preserve the information. So yeah, that's dimensionality reduction. Thank you so much, and I will catch you guys next time. If you like this video, please like and subscribe. It really helps the channel. And if you have any other questions or comments regarding this video, please post them at the bottom. And take care. See you next time.